In this lecture, we're going to talk about design of torsion reinforcement, specifically torsion reinforcement in beams, non-prestressed beams. So first of all, when do we need design of torsion reinforcement? When do we need torsion reinforcement in beams? We need torsion reinforcement in beams when TU, which is the factored applied torsional moment, is greater than the threshold torsion that we talked about in our previous lecture. This threshold torsion for non-pre-stressed members is equal to phi square root of f prime c ACP square divided by PCP. As you may remember, ACP is the area enclosed by the perimeter of the cross-section. PCP is the perimeter of the cross-section. F prime C is the compressive strength, and phi is 0.75. So whenever the applied external factored torsion is greater than the threshold torsion, we need transverse reinforcement and longitudinal reinforcement to resist torsion. So this leads us to the two types of reinforcement that ACI accepts or recommends for torsion reinforcement. Number one, longitudinal reinforcement, presented here in red, and as the name suggests, it runs along the beam. And transverse reinforcement, which takes the form of stirrups, closed stirrups, spaced at a uniform distance S. Okay, so basically two types of reinforcement that need to be provided for torsion: longitudinal and transverse. Longitudinal is AL and transverse is AT. Let's see what ACI recommends for each one of these. For transverse reinforcement, ACI recommends in 11.536 an amount of transverse reinforcement that gives you a nominal torsion equal to 2 times A naught times AT times FYT divided by S, all of that multiplied by cotangent of theta. From this equation, let's first define AO. AO, or A naught, is defined as 0.85 of AOH, and A naught H is the area enclosed by the center line of the transverse reinforcement. So if this is the cross section of a beam and this is the transverse reinforcement, A naught H is this area in here enclosed by the transverse reinforcement. That's A naught H. You multiply that times 0.85 and that gives you A naught. That's the value that goes in that equation. AT, going back to our figure, AT is the area of transverse reinforcement of one leg of the stirrups, right? So it's important to keep that in mind because that's different than in shear, where we are looking at the total area of the stirrups. AT is the area, cross-sectional area of one leg of transverse reinforcement. So it would be the area of that leg shown there as AT. FYT is the yield stress of the transverse reinforcement. S is the spacing of the transverse reinforcement, and cotangent of theta is a factor that accounts for the inclination of the torsion-induced cracks in the beam. And for non-prestressed members, theta is recommended as 45 degrees. Basically, this formula gives you the nominal torsion strength of the beam with a certain amount of transverse reinforcement spaced at a certain distance. You must remember that for a design to be adequate, phi times Tn must be greater than Tu. And so you need to provide enough transverse reinforcement to satisfy this equation, right? The basic design equation. Now, ACI also states that along with transverse reinforcement, you need to provide longitudinal reinforcement. As I'm showing here in red, longitudinal reinforcement to also intercept the cracks that will form in torsion. And that formula can be found in 11.5, 0.3, 0.7, and it includes the area of one leg of transverse reinforcement divided by S, right? So that's this term right here. It also includes this term pH. What is pH? pH is the perimeter enclosed by the transverse reinforcement. So if this is your beam and this is your transverse reinforcement, and here you have your longitudinal reinforcement, pH is the perimeter of this, right? Perimeter of transverse reinforcement. FYT and FY are the yield stress of the transverse reinforcement and the longitudinal reinforcement respectively, and cotangent of theta square is going to be taken again with theta at 45 degrees. And basically these are the two equations that define the transverse and longitudinal reinforcement for torsion.